Hi, welcome to the new video, and today we are discussing about strain and its type. So, let's start with the strain. What is the strain? So, whenever we apply some stresses on any subject or any material, so during that time, they goes under some type of deformation, and due to this deformation they change their dimensional, which have they have some changes in their original dimension. So for the ratio of the change in dimension to the original dimension, it's called a strain. So what is a strain? We can see over here, strain, so change in length divided by original length. For an example, there is one bar over here. We are pull it out from the both the side with the force P. So after some time, it will be like this. So this length will be 1 meter, and after then it have the change, like the length will be 1.5 meter. So this change is called as a strain. And if we find how we if we have to find the strain for that, so what we put in the equation. So 1.5 is the change in length. It's also called, the equation is over here, the delta L by L. So what's the delta L? 0.5. How it's come? So original is 1, and we have to find the final from the initial. So it's 0.1 divided by 1. So the strain will become at 0.5, and strain never have the unit. Strain never is a unit dimensionless quantity. It does not have the unit. So what's the changes comes in the strain, and what's the types? So first of all, the first type is the linear strain, which is always come due to the tensile stress or the compressive stress. What's the definition for that? Is when the body is subjected to tensile or compressive force, change in length per original length is called as a lateral, is a linear strain or the longitudinal strain. So what's the equation is? This equation is for that, and I give the example of for that, the bar one. So delta L is change in length, and the L is the original length. So what's the type? The tensile strain, in the tensile strain, the length is increasing. But for the compressive strain, the length is decreasing, because for that we are applying the force in the inner side. So the bar will be like this. So it will be like 0.7 meter or something. It's not increasing. Okay. Over here I have one example for you. So road have the 100 mm length, increased by 2 mm after the applying the stress. So what's the linear stress? So linear strain is equal to 0.2 divided by 100. So it will be 0.002 mm. Oh, it does not have the, because the over here is mm, over here is mm, so mm cut. So it's a unitless. Okay, so no unit for that. Well, the second time is the lateral strain. Lateral strain, in the linear, we change in the length. In the lateral, due to the sum type of stresses, when we apply the stress, the material, or we can say the subject, there is a diametrical change in the subject, not in the length. So what's the definition? When the body is stretched, its length is increasing, but the cross-sectional area is decreasing. Like we can say the diameter is decreasing. So what's the example of that? There is a one shaft over here. It's of the length of 1 meter. It's at the diameter of 0.5 meter. After applying the pull force from the both side, what happened? The length is increasing. So like it will be become a 2 meter, but due to the pull force, the diameter will be decreased and it will be become around zero point 0.3, zero point 0.2. It's just the example, but it's happened. Like whenever you for an example, you have a pen and you like pull it out from the both side. So the center part will be the diameter of the center part will be decreasing with in respect to time. So what the equation for that is the change in diameter and original diameter. Over there we have the length, over here is with the diameter. There is the important for the sums Poisson's ratio. It's always given in the sums or in the standard things. So Poisson's ratio, what is Poisson's ratio? So the ratio of the lateral strain divided by the, like to the linear strain is called as the Poisson's ratio. And the Poisson ratio is denoted by mu. And it always between the 0.25 to 0.35. For the steel, it's the standard 0.3. What was the next type is the volumetric strain. It's like due to the force, if there is the change in the volume, so it's called as the volumetric change. But the same, when the all dimensional changing, change in volume per original volume is also called as a volumetric strain. For the same equation for here, uh, yeah. Now the last thing, the shear strain. Shear strain is due to the shear force. Like when we apply to two, there is a two parts which are together with the bolt. We apply force over here and force over here. So over here it will be generate the shear stress on this surface, this one, the middle part. And due to this shear stress, the strain is generated, which have some angle phi, like it will be become like this, like this. So this one is the phi. So the phi is the angle of distortion. So we can see the definition. When the shear force act on the body, angular distortion occurs, like I said you. There is the it's go with the some angle because we are this is going this side, this is going this side, so it will be by like it's if for example is over here, we press over here, we press over it. So what happened? It will be become like this. It's tilt. It's and the angle. So it's like the same. Uh, in this for the smaller angular for the smaller angles, we can like the take tan phi is equal to 5. So sometimes the shear strain is directly value of the strain the phi. The last thing is a thermal strain. It's come due to the temperature difference. And what's the equation for that? So it's alpha into delta T. What's the alpha? Is the coefficient for the thermal expansion. And for the all the material, for the all the temperature, it's always different. So we have to take from the standard tables. And the delta T is the changes in the temperature. So we can, I have one short table for you in from which you can easily prepare for your MCQs or the short answer question. So over here is the type of strain. Over here is the type of strain. Is the formula for that, and is the why its causes. So is a longitudinal stress or the linear strain. It's due to it have the equation of the delta L by L, and it's due to the axial force. Axial is the tensile and compressive. Both forces are called as axial force because it's or apply in the x axis or the y axis, not at the any angle. Okay. Then the lateral strain have the equation, and it's also from because of the axial force. But the volumetric strain is the change in volume divided by original volume. It's because of the 3D change, because like volume is have the like for the rectangle, like the square, like for all of them is a 3D change, that due to that is the come in the volumetric strain. The shear strain due to is a tan phi equation is because of the shear force. The thermal strain is come with the temperature changes, and it's the equation of the alpha into delta T. So thanks for be with the MechCAD Academy, and subscribe for the more videos related to mechanical theories, CAD designs, and numericals.